Hi, everyone. Be still awake? Woo! It's the end of a long and exciting day. If anyone hasn't noticed, by the way, it's raining inside the Javits Center. So that's exciting. None of the other summits this year had rain inside. So feeling pretty proud of New York for achieving something that all the other summits this year did not. Hold on. Woo! So my name is Abby. I am a developer evangelist for AWS. I've been upstairs in the Twitch booth all day, making a special guest appearance today to talk about AWS Fargate. So a little bit of intro. So what's a container, right? So it's an atomic, self-contained package of software that has everything that it needs to run. And everything that it needs to run includes its application code, its libraries, its binaries, everything that it needs. So a pretty popular and widely used platform for this is Docker. So if you've ever been to one of my talks before, you know that there's usually a lot of links in there. So as is tradition, I have included some links. So when this deck is posted after the summit is over, you'll be able to follow along with the links on your own time. So over the last couple of years, I think we've seen an ever-increasing amount of these kind of talks and blogs and tweet threads and all that good stuff about containers. There's also been serverless, but today we're team containers. So why are containers so popular? So they're portable, they're lightweight, they're standardized, they're easy to deploy. A story comes along with them, I think, for a lot of people, and that's the whole monolith to microservices story, right? So containers and microservices feel like they go hand in hand, and I'll talk about that in a second. And I think what containers really enabled for me, so I was an AWS customer before I came to work here, and this is like my second anniversary of doing anything AWS related. So not last year at the New York Summit, but the year before, I was a customer speaker instead of an AWS speaker. So I'm happy to be back at my hometown summit talking about actually something really similar. So I'm once again back talking about monolith to microservices. But what those containers really enabled for me is that, so who here has worked in ops before? Me. And you know that a really common problem, right, is the whole, well, it worked on my machine. Or it works in production. I don't know what's wrong with staging, but you know, it worked when I did it. It worked when I tried it. It worked when I tested it. Or it works for me. It works locally. And containers, for me, removed a lot of that because they could kind of work everywhere, that I could take that standardized box and I could move it from my local environment to my staging environment to my test environment to my production environment. There's actually a good quote that's been floating around too that says, everyone has a test environment, and some of us are lucky to have a production environment as well. And containers, I think, kind of helped eliminate some of that because it makes it that much easier to set up these repeatable environments where I can test in the exact same situation as I could in production. So what are microservices? So I said that there's this big monolith to microservices story. So there are many definitions of this, and I'm not going to do the whole Merriam-Webster dictionary thing, although they're amazing on Twitter, by the way. They've started really clapping back at people, and I am here for it. So this is Adrian Cockcroft. We used to call him the best AWS evangelist that didn't work for AWS. If that joke was ever funny, it's no longer funny because he works here now. So Adrian says that it's a service-oriented architecture composed of loosely coupled elements that have bounded context. So what does that mean? Service-oriented, it has a job. It has loosely coupled elements, so my elements are not tied together, so I don't have to edit one service in order to deploy the service that I'm actually working on, and they have bounded context. So for me, that means it has a job, and it does not do more than the job. So if I have a messaging service, and it starts to handle my internal dashboard, it's no longer just a messaging service. And with this definition, we then break it apart. So it's not just getting from my monolith to microservices, but it's keeping my microservices services with bounded context. So it's keeping them where they have a defined job. They're not tied to anything else. So if they communicate with another service, they do it via the public API like anyone else. And that if it goes beyond the scope of what that service was intended to do, maybe it's time to be 2 services or 3 services or 4 services instead of just one. So why do they go together? So we talked about this a little bit just a second ago, but one job, one service, for me, often equals one container. So maybe I have my messaging service, so we'll keep the same example. That service runs inside of a container. And I can start up more copies of that container if I need my service to process more requests or more items off a queue. But my one job, one service for one container. And I can move those pieces independently. So previously, with a monolith, if I had to scale something up or down, I had to have a whole new copy of the monolith, regardless of whether my different services all needed to be scaled up. And with microservices, that lets me kind of do both, right? So if my internal dashboard service gets almost no traffic, but my messaging service gets a significant amount of traffic, I can scale up only the messaging service without touching my internal dashboard service. Unfortunately, if you've been to any of these talks before, or if you've done anything with containers, you know that managing one container is pretty easy, or easy-ish, but managing many containers is much harder. So we have something called orchestration tools. So orchestration tools are what help us kind of manage, deploy, scale all of these container moving pieces so that we don't have to do all that heavy lifting ourselves. And in Amazonian terms, that's how can we do less undifferentiated heavy lifting? That's what that means. But how can I get all the advantage of these containers, like using every nook and cranny of an instance or scaling up the pieces independently, but how can I do that without having to sit there by hand and kind of move everything on my own? So that's an orchestration tool. So here's a couple of them. So ECS, Kubernetes, Docker Swarm, Mesos, there's all kinds of orchestration tools out there. And ultimately, they're all solving a similar problem in slightly different ways, or very different ways, depending on what the tool is, right? That how can I deploy, manage, and scale all of these moving pieces? And if you're just looking at AWS, because this is an AWS summit, there are a few options on AWS for this container orchestration. So a little bit of recap before we dig into things. So Amazon ECS, available now. It's been available for quite a while, I believe since 2014. That's what I used as a customer. You have Amazon EKS, so the Elastic Container Service for Kubernetes. ECS is just Elastic Container Service, and we'll dig into these in a second because the acronyms are confusing. Then there's Fargate mode for ECS, which is also available now, I believe in 6 different regions. And then Fargate mode for EKS, so to be announced, coming sometime soon-ish. So what are these all for? So kind of moving from the bottom up. So image registry, so where can you store all these different versions of your images? It's Amazon ECR. The management part of that, so what I just kind of talked about, the deployment, scheduling, scaling, all that good stuff. ECS or EKS. Hosting, so where the containers run. Fargate or EC2. I think that that's a little bit misleading, right? Because ultimately, one of the dirty secrets I feel like of the internet is that, I don't know, it feels like everything just kind of runs on EC2 at some point, right? So Fargate is a layer on top of that, and it means that you're not managing any of those EC2 instances yourself, but there is still EC2, because every time I say anything, someone tweets me and says, there are still servers and serverless. There are still EC2 instances in Fargate, but you're not the one personally responsible for them. So there you go. So what does this look like if you're confused by all of the acronyms? So if you want to run a managed container on AWS, your first step is what you want your orchestration tool to be. So that's ECS or EKS. So that's basically the Amazon version or Kubernetes. We use the same open source version of Kubernetes as you can all on your lonesome. After that, you choose your launch type. So right now, that's EC2 mode or Fargate mode. Confusingly enough, EC2 mode is what was just regular ECS before Fargate came out. So if you've been using ECS from before Fargate, what's now called EC2 mode, that's what was traditionally just ECS. And now you have another option, which is to run it in Fargate mode. And what that comes down to is how much control do you want or need? So with Fargate, only manage things at the container and task level, and at ECS, manage everything down to the EC2 level. So it's a balance between how much control you want or how much control you need, but that's the choice. For EKS right now, only in EC2 mode, so it's like the original ECS, with Fargate mode, so the EC2-less mode coming sometime other than now. So, Fargate, because today is only about Fargate. Someone was outside and I thought that they were talking to me, but they weren't. Anyway, so Fargate, no instances to manage. everything kind of scales up and down for you. So you can define things the same way that you could in ECS with it, which is here's when my service should scale up or down, but there's no like provisioning pools of infrastructure. So with EC2, right, in EC2 mode, so ECS traditionally, I realize that this is confusing also because everything is secretly named ECS. With traditional kind of ECS and EC2 mode, you have two levels of scaling that you're responsible for. The service level, which is the task level, so how many copies of each task do you want running, and then the EC2 level, so how many instances belong to my cluster. Fargate only do the service level scaling, the same kind of AWS integration as you get with other services, so VPC, load balancing, IAM permissions, Cloudwatch, all that good stuff. So what are you talking about? Remember this, right? So running one container is easy, but managing many containers is harder. ECS makes that easier, right? So handle some of the scheduling and orchestration. We talked at the beginning about why we needed orchestration tools. You have a cluster manager, you have a placement engine. That's what determines things like I say that I need 4 copies of this task running. ECS will handle that for me. If it scales up in response to an event, it will handle that for me. So ECS makes that easier. And this should be familiar to a lot of you. Scales, you get service integrations, things like that at the container level. You can integrate with other AWS services. But it's not totally hands-off still. So Fargate, it lets you focus on your application, right? And my favorite way of explaining this is when someone asks you for a sandwich, they aren't asking you to put them in charge of a global sandwich logistics chain. They just want a sandwich. So they don't want to know how to slice tomatoes, or where do you get turkey from, or what kind of cheese do you want, or how do I toast the bread, or is mayo really an acceptable alternative to mustard or Miracle Whip? They don't care. They just want to eat the sandwich. So Fargate for me is just a sandwich. I don't have to worry about how it happens or how it's made or how you eat it. It's just there. So people are using this. So Product Hunt is a good example. So they run their whole website as microservices, so Ruby, GraphQL, Node.js frontend, and they were looking for a way that they could scale really quickly and then schedule multi-container workloads, but still have control over their network layer. So they've been all in on AWS. They moved their whole infrastructure to AWS and Fargate back in January 2018. Fargate scales quickly with its traffic spikes, so it lets them do things like scale up really quickly in relation to an announcement or a viral campaign. We've used Product Hunt before. It's kind of a good example of things going viral, right? Because it's posting new services, new apps, new things, and then the whole kind of point is that that's how you can discover new content, so new applications, new apps, new games, new products. So it's important to them that they can scale up really quickly in response to something like a quick traffic spike, because they want to be able to handle that. Prior to that, all their infrastructure was on Heroku for the last 4 years, and they have a lot of inter-service communication. They didn't want to, so they had I think a pretty cool use case, right, where they had a lot of complicated stuff going on network-wise, but they didn't want to manage their own infrastructure. They only wanted control over the part that was important to them. So here's a cool architecture diagram. So you can see how it's working right now. So it goes through an application load balancer. That's what ALB stands for. Can route through their private subnet, so to their backend web service, their front-end web service. They have a card or scraper service. Then that goes to an internal application load balancer or runs background jobs and Sidekick. Goes then to their internal servers, and then it backs everything with Redis and Postgres. And this is a quote from Product Hunt, and they said that they moved to Fargate because they needed to be able to scale up really quickly from the baseline, run these multi-container workloads, but then keep that network control. So the same use case that I just explained, right, which is that they needed control and the ability to customize over the parts that mattered to them, but they didn't want to kind of manage all the other EC2 parts. So a couple other ones for you, Accenture, Product Hunt, Smartronix, all kinds of cool stuff. So let's get deeper. So the easiest way I think to think about Fargate is in comparison to ECS and EC2 mode, because I think that that's kind of the baseline for which this makes sense. So the way that it looks, if you're in the console, and this is probably the first time that you can see a big difference, right, is that you go to create a new task definition, so you go to get started, and And your first choice is which launch type you want to run it in. So launch type mode are synonyms in this particular case. So you pick from there, and then you get a difference in how things are controlled between the two of them. So how do the pieces of ECS map back to traditional workloads? So if you're still in the kind of breaking it down from monolith to microservices stage, this is a good place for you to be at. So an instance is an EC2 box. So once you've registered it to a cluster, you can run and place your tasks there. A service is how you manage and place your tasks. So that's what controls, I have 2 copies of this running and 6 copies of this running and 1 copy of that other task running. And a task is that container wrapper around a process that's running on the instance. So these are all very comparable back to things that you would run kind of outside ECS, right? They're all the same familiar pieces, just kind of structured a little bit differently. So with ECS, you're responsible for all 3 of these kind of sections. So instances and services and tasks. You configure those through an AMI, so either through the ECS optimized one or through EC2 user data, if you're me. Services and tasks can all be configured through the API. You can either access that directly or you can go through the CLI. Tasks go through task definitions. Containers go through container definitions. So compute works, you choose your own instance type. You get any kind of combination of resources that you want. You can control that through an auto-scaling group launch configuration like you would for any other set of EC2 instances. Supports things like Windows, GPUs, spot instances, RIs. Bring whatever instance type you'd like. So Fargate, a lot of similarities and quite a few differences. So same schema. So define everything through a task definition. Use the same set of APIs to launch Fargate containers. Easily switch back and forth. So you can actually run hybrid clusters too, because people always ask me which one they're supposed to use, and like when should they migrate all the way over or migrate all the way in the other direction. And I think that for me, what it would probably look like is I'd end up running both. So I'd keep things in EC2 mode if I needed a level of control over things like EC2 user data, or I needed to use a spot instance or an RI, or I needed to attach a GPU. And I'd use Fargate for things that I didn't need access to those things for. So if I could define everything that the task definition and the container definition, I'd use Fargate, and if not, I'd use EC2 mode. But you can run them side by side in the same cluster, so the same cluster can have both launch types in it. That's also how you migrate, by the way. So I actually had a customer on Twitch earlier today. I think it was Harry's. And when they switched over from EC2 mode to Fargate mode, they basically made equivalents of all of their services in the Fargate launch type, and then different paths in their ALB, and they just switched traffic over because ultimately they're just changing the launch type so that they could make equivalents to all of their services just with a different mode. You share primitives between Fargate and ECS or an EC2 mode with all kind of the familiar AWS pieces, so VPC, Cloudwatch, IAM. So for Fargate, you're responsible for only 2 of these sections, so services and tasks. Instances are not configured by you, so that means less work, but also a little bit less control. So you can't currently use things like GPUs or RIs or spot instances. You can't choose your own instance type. Fargate just handles placing things for you. Same way to control and configure everything, though. It's still through the same set of APIs. So compute works a little bit differently in Fargate too. You can't choose any combination. You can choose from a set of combinations. So a sliding scale of CPU to memory. So not infinite resources, but can get some pretty hefty tasks in there. So how do you know what to choose? And ultimately, and everyone always yells at me for copying out the answer here, but it depends on what you're doing, right? So the answer for me is not the same answer for you or for the person sitting next to you or for the person in the back of the room. It's what you want to do. So I think for a lot of people, what maybe makes sense in a lot of scenarios is that if you're starting out and you're just moving over from monolith to microservices, or if you're just kind of feeling out the whole container thing, maybe start with Fargate. And then as you find that you need maybe a little bit more control for a certain task, or actually I needed to support this Docker option that's not supported in the UI, and I need to do that through EC2 user data, maybe look at running something in EC2 mode. And you don't have to switch everything. It's not one or the other. It's a combination of both. For some things that you might need to customize, you'll want EC2 mode. So getting even more specific, so we're going to walk through how you'd build something like a tic-tac-toe game application. It's called Scorekeep. And then we're going to look at all the different pieces that you'd want to configure our application. So compute, networking, storage, permissions, and logging. So constructions in Fargate, or constructs in Fargate. So first, I have to register my task definition. We talked about that earlier. That's how kind of I define everything. That's what container image that I'm using, so the URL that I'll pull it from, my CPU and memory requirements. I then run a task. That's a running copy of my task definition. I need to use the Fargate launch type. I'll have to create an elastic load balancer. So for Fargate, I can only use application load balancers or network load balancers. I can't use the ELB classic. Different reasons for that. I think, by the way, that if you're using microservices and containers anyway, that you're better served by an ALB anyway. And that's because it lets you do content path-based routing. So previously, so if you were using an ELB classic with microservices, I basically needed to have one ELB for every service. So if I ran a staging service and a production service for 15 different internal services, that was a lot of load balancers. And not only is that annoying and there's many pages to scroll through, I can never quite find the one I want. It's kind of a funky process, and it binds you to another resource requirement, which is port, right? So if I have an application that runs in a specific port, so we'll pick 8081, because for some reason that's my favorite port. I do not know why. I only have one port 8081 on an instance, and it is a hard restraint. To get any more port 8081, I need to have a whole new instance that has one more of my port 8081. But that to me seems a little antiquated, right? Because if I'm not scaling up with one whole instance, like I am for a monolith, why should I have to scale up just because I want port 8081? And they were like, well, Abby, what if you wrote your own logic to dynamically choose a port? And the answer would be that I do not want to do that. I want something else to allocate the port for me. So I have good news. So that's kind of my favorite, maybe underlooked feature of ALB is it lets you do dynamic port allocation, which means that I can pass in port 0. I only pass in my container port. I pass 0 as the host port, and then I use a target group in the ALB, and that will allocate the port for me, which means that my application that was previously bound to 8081 can now be on many different ports, which means I am not scaling up EC2 instances just for funsies. So that was a digression, but that's why I'm pro application load balancer. So service, you create and maintain n running copies of your task. In a lot of cases, that might mean that I have a minimum number. So I always want probably at least 2 because we want high availability kids. I have a minimum number, maybe a minimum number of 2. I have a desired count of 4, and then I have a maximum count of 26, right? And what controls how I scale up and down is that service level auto scaling rules. But the service is what's responsible for saying, hey, I have 2 copies running and I was supposed to have 4, or hey, this rule was just triggered, I should run 2 more. I can integrate that with the load balancer. My unhealthy tasks get replaced automatically. On top of that, my top level is my cluster. That's what defines kind of the boundaries of my infrastructure. It gets an IAM permission role where you can access it and where it can perform actions on your behalf. So a task definition is just a version document. It's immutable. So when you do different copies, different like updates to your task, so if I change my application code and I push a new image to ECR or Docker Hub or your own private registry or wherever you're keeping your things, I do that by pushing a new revision of the task definition. So if you're working with this, it looks something like Abby's task definition :1, Abby's task definition :2. I give it a family. My family would be Abby's task definition. Within that, I get up to 10 container definitions. Containers are all co-located on the same host. So if you're into networking, that means that they can communicate via the local loopback interface or 127.0.0.1 or localhost or whatever you're calling it now. A container definition has a name, it has an image URL, and it has all kinds of other things. So for ECR, for Fargate, ECR or public repositories, hopefully private repositories coming soon. For compute resources, this is how you'd end up setting it. So we looked at the sliding scale earlier, but I have task level resources and I have container level resources. The task level means that it's shared between all containers. They are required. Container level resources controls the relative sharing of those resources between containers. So that might be something like I reserve 512 memory for this particular container, but I have no memory reservation for this other container. So task level is required, that's the total. Container level resources are optional, and that's how you relatively split that around the containers that are running. That's good, by the way, for things like if you have something that requires very little resources, you can set that here, and it will let other more resource-intensive containers that are part of that same task definition take more of the resources that you've allocated to that task. So pricing, you pay for what you provision. You're billed at the task level for CPU and memory per second billing, which is the new thing. So let's talk about networking, because you didn't think that you could get away from any of my talks apparently without talking about networking. Even though it's 5:45 p.m. and everybody is sleepy, I swear it will be painless. And if you're watching this video later, maybe you'll be also excited to talk about networking. So traditional Docker networking, you get 3 types. You get Docker 0, that's the default behavior, that's called bridge. It means that containers in the same network can communicate via their IP address. No automatic service discovery, you can connect them with -- link. None, no network interface, only the local loopback, which I say that I'm going to explain shortly, and then I deleted the slide. So I'm not going to explain that shortly. I guess I'll explain it in just a second. Host, you can map directly to the host network. I have good news and I have bad news. So the bad news is that Fargate uses a different networking mode that is option E, none of the above. We're going to talk about that. So when I launch a Fargate task, it launches into a subnet. We create an ENI, that's an elastic network interface. That ENI is allocated a private IP from your subnet. If you're using Fargate, you can optionally assign it a public IP. The ENI is mapped to that task, and your task now has just its own private or public IP from your subnet. I can then configure everything through security groups. What this means and what this allows us to do is that containers on the same host can use a local loopback interface, which I didn't explain, but now you know. That's what lets things communicate. So localhost or 127.0.0.1. Containers on the same host can always communicate that way. But if you've attached the ENI directly, it means that containers that are not on the same host can now communicate via that ENI. So via that private IP or public IP, chirping birds or crickets. Anyway, so what that means is that it simplifies your networking a little bit. Because instead of having to go out through the internet, looking up how to speak to your container and then going back down, you can just communicate through that ENI and through that private IP. So it's called AWS VPC. It is the only networking mode that is available for Fargate. So when I said earlier that you only needed to change your launch type to work with Fargate, I was lying a little bit. You also have to change your networking mode. See how I really just snuck that in at 5:30 p.m. just for you? Yeah, so you also had to change your networking mode. But it's one of those things where, like moving to application load balancer, that I think is a good thing. It just might take a little bit of work for you to switch over, but it is, I think, a positive thing, because ultimately, I mean, unless you like talking about networking as much as I do, it simplifies the process for you quite a bit. So it's a good change, but it takes a little bit of work. So VPC configuration, things have to run inside VPCs. Here's the part in the task definition where it enables that ENI creation. It's just passing in AWS VPC as the networking mode. Again, if you're doing Fargate containers and if you're creating these to the console, you'll have no other option. If you're switching over from EC2 mode, you'll need to make that change yourself. So for load balancing configuration, you do that when you create a service. You can't change that. So once you've registered your service with a load balancer, you cannot change the load balancer or rename it. You would have to add a new load balancer and recreate the service and re-register it with the load balancer. So You can only do it at create service, can't change it. Here's an example of what this might look like if you want it internet facing. So my task is running in a private subnet. It has a private IP. I have an application load balancer in a public subnet with a public IP. I have 2 availability zones. I have an application load balancer security group that allows inbound traffic, and then the security group can allow inbound traffic from the ALB to my actual tasks. So for storage, disk storage, EBS backed ephemeral storage, you have a writable, it's a hard word to say apparently, writable layer storage and volume storage. So layer storage, so this is one of my other favorite things to talk about. So apparently I like to talk about all the cool things, which is port allocation and disk space. Those are my top 2. So layer storage. Docker images are composed of layers. So that's a stack of read-only layers. It's often an operating system or layers that you built on top of, and then you get a relatively thin read-write layer on top of that. That's file changes or any data that you commit to the running container. You get 10 gigabytes of layer storage available per task across all containers. That includes image layers. Writes are not visible between containers, so if I write something in one container, I can't just see it in another. Ephemeral, that means the whole cattle not pets things. When the task and container stops, goodbye. So if you have something that's super important that you want to share, perhaps store it somewhere that is not ephemeral. So volume storage. If you need your writes to be visible, so across containers, you can do 4 gigabytes of volume space per task. You can configure where you mount your volumes and your task definitions, mount at different paths. Also ephemeral, so once the task stops, the volume is no longer running as well. So for IAM permissions, you get a couple different types. Because this is 5:30 p.m., I saved you from multiple slides detailing every level of this. So now I just have one slide to rule them all. Your top level is your cluster permissions. So that's who can launch and describe tasks in your cluster. Next, you have application permissions. So that what can your applications do to access AWS resources. And then you have housekeeping permissions, which are us permissions. And that's what lets us do things on your behalf. So things like pull images from ECR or create ENIs or register targets in your ELB. So for visibility and monitoring, Cloudwatch is really your best option here. That's AWS logs driver if you're configuring it through the CLI or through the UI. You create a log group in Cloudwatch. You can configure the log driver through your task definition. And then you have to add, obviously, permissions via the task execution role. The task execution role is what that task can perform on your behalf also. Here's what it ends up looking like. Everyone has probably seen this before. Other visibility tools. So Cloudwatch emits a lot of events, and if you're not into Cloudwatch, you can consume those events in whatever format your heart desires. So you can bring them other places, you can use other monitoring platforms, you can use visibility platforms, you can use observability tools. The world is your oyster. Cloudwatch is really good, I think, at emitting and producing a ton of events. And you get those kind of natively. So pretty much every AWS service will emit events that can be consumed by Cloudwatch. Great for triggering alarms and auto-scaling groups and alerts. Not always the most visually attractive option, which is fine. So if you have a different graphing tool or if you've written your own custom logic around deployments or alerting, you can consume those however you'd like. For Fargate, service and service CPU and memory utilization metrics will be available in Cloudwatch. So what that looks like altogether, if I want to run my application, I end up kind of with 3 different pieces. I have my task definition, I have my front-end container definition, and I have my API container definition. If you want to run this yourself, it's on AWS Labs. So there's at least two. AWS kind of official ones on GitHub. The first one, there's just an AWS one, and that usually has things like the CLI. But there's also AWS Labs, and there's also one that I believe is called AWS Samples, and I can't remember if it has a hyphen in the name or not. But if you look for it, you'll find it. So AWS Labs has all kinds of good stuff on it. Sometimes you have to dig for it a little bit, but there's tons of demo projects and workshops and walkthroughs and all kinds of cool stuff that you can play with on your own time, or you can pull and you can run. AWS samples will often have some more generic samples, so like CloudFormation templates that you could build off of for just like a generic backend server example. So check both of those out if you're looking to obviously build things other than just my very small examples in this. So what do we learn about Fargate? New launch type. If you're debating between both of them, maybe try starting with Fargate. If you think you need access, I actually had a really cool customer conversation today where they said that they were happy to be using Fargate because it just removed the whole option of people being able to exec into containers, and that what it forced them to do was consume those events in a way that let developers have the same kind of tooling, but without requiring access to the actual container itself. I think that's really cool because I think a big problem is, I guess for CloudFormation or something, we'd call it like configuration drift. So all those things that happen between me applying the template and then you running it, or then maybe I SSH somewhere and I just do that one thing, or maybe like someone else does it, or like maybe I SSH'd in there and then I pulled something, or I deployed a different version, and they said that because they didn't have access to do that anymore, that it forced them to always update things in their code and in their configuration, and that it kind of removed a whole area that had been causing them problems before. So there are some good reasons to require access to this. So to use EC2 mode, obviously, also, so things like dedicated instances or RIs or spot instances. So ultimately, it depends on what your actual use case is. I'm not going to read this whole thing out loud. But for me, I think it really comes down to the level of customization that you're wanting to do. I'm always for the best combination of the least amount of work and only customizing the things that I really personally need to do. So find the balance that works for you. But you don't have to do it all by yourself. So I do not expect anyone in here to be going to the console every day and hand crafting Fargate containers. That sounds terrible. So CLIs that I know of for Fargate or ECS, generally they're shared because since they're two launch types or two modes for ultimately the same overarching service. Often CLIs will support both of them, so the official CLI is the same for both Fargate and ECS. There's actually two of them. So the AWS CLI is the OG, it's the original one, it's open source, it supports pretty much all AWS services, so you can use the same CLI for Lambda and Kinesis and Recognition and ECS and Fargate and everything. I included links for it if you're interested in that sort of thing. The ECS CLI is also official, but it's just for Fargate/ECS. Biggest differentiator is that it only supports those two and not any other AWS services, and that it supports Docker Compose files. So more information on that GitHub page. I would say that the strongest factor for the ECS CLI is Docker Compose. So if that's a format that you're really invested in, the way that you can support that on AWS is through the ECS CLI. There's some good unofficial options. So the Fargate CLI is written by one of the AWS solutions architects. It's called the Fargate CLI, which is awesome naming. I like that one because it feels a little bit like the Docker CLI. So like Fargate task run X, or like Fargate service run whatever. And it feels very Dockery to me. So I like that. So what's next? So most importantly, I think we want to hear from all of you. So what we're thinking about in the future, more focus on supporting these tasks, the compute primitives. We talked about that at reInvent, and then probably again at the San Francisco Summit and at the London Summit. But what's been really striking to me over the last couple of years is watching us support containers as kind of a fundamental compute primitive. So instead of always having to jump back out to the EC2 level to do things like security groups or permissions or auto-scaling rules, I can do that at the task level now as well. And I think that that's really cool for me, right? Because I shouldn't have to manage things at the EC2 level when all I really want to run are the containers. And I like seeing more and more things get supported at the task level, so like load balancing and networking. It's all at the task level now. But most importantly, what we build is driven by feedback from people like all of you. So things like joining a user group or a meetup or coming to a summit or reInvent or hanging out with us on Twitter or Twitch, that's what drives our roadmap. So let me know, let your account manager know, let your friendly neighborhood SA know. But let us know what you want to see. So both from Fargate or ECS or EKS, and that actually goes for anything else on AWS too. So if you learn anything from hanging out and talking about networking at 5 p.m., tell someone, right? If you want to see something, if you want something to be implemented a certain way, let us know, because that's how we know what to build that will make the developers that are working with AWS happy. How can you get started? So I added some links for you all. So Fargate, like a lot of AWS services recently, has something called a Getting Started wizard. So if you go to the console, it will walk you through the pieces of a Fargate task and what the different pieces mean, and it will help you set it up. There's a couple blogs in there. That's what the wizard looks like, by the way. It's that big blue bar. So if you haven't been to the console recently, that's what that bar will do, is it will walk you through Fargate. There's also something called the Awesome ECS project, and that's on Nathan Peck's GitHub. So Nathan is one of the developer advocates for containers here at AWS, and he wrote this really cool GitHub repo that's basically just community-sourced content on containers at AWS. So it's blogs and workshops and demos and cool open source projects and tooling, but it's all there. If you've written something, by the way, that's not included there, you can open a pull request and he looks at them and he merges them. But it's a really nice kind of community-backed piece of content, or lots of pieces, or repository of content. I don't know what word I'm looking for, but maybe it's repository. It's all together in one place, and you can look at it. So if you're looking to see, because that's how I feel like I learned myself, was by seeing what other people were doing. And chances are, if I'm trying to solve a problem, someone else has probably already solved it. Or if they're also struggling with the same thing that I am, maybe they'd want to see me writing about it too. That's actually how I got my job, is I wrote a blog post on how, as a customer, I moved to ECS. So the problems that you're working on are not always unique, right? That there's someone out there that could help you, that could write about it. So you should also be that person and write about it and go talk at a meetup or go talk at a user group or come hang out with me on Twitch. There's also a bunch of workshops. So here's one by Brent, who is, if you were at the Fargate talk earlier, this is the repeat of. Brent is another one of the developer advocates for containers. We have many. But he wrote this really cool workshop for Fargate that walks you through, I think, like a more thorough example. So it has a back-end service, it has a front-end services, it walks you through all the pieces. It's actually pretty nice. It shows you how service discovery works. If you need a little help other than that, there's some Slack channels, because everything now has a Slack channel. I'm thinking about making my houseplant a Slack channel so that everyone can join me and discuss my houseplant. I'll hopefully get a lot of notifications about it. It's awsdevelopers.slack.com. For my sins, the best way to get into that is by messaging me on Twitter and sending me your email address. And within 7 to 10 business days, I will probably see your message, and I will hopefully add you to the Slack channel. I try my best. Terrible Slack gatekeeper. Hopefully we make it public soon. There's also a community-run one, which is probably faster to get into. There is a lot of people, though, in the AWS developers one, so possibly worth my terrible turnaround time. And there's channels for lots of other things. So there's a lot of people hanging out in the serverless container, the serverless channel. There's a containers channel. There's a general channel. And there's a bunch of AWS employees and service team members hanging out in there as well. So if you have a question and you're looking for someone on the service team to answer, that is a sneaky way to maybe get an answer from someone on the product teams, or from me, or from one of the other developer advocates. Or you can reach out to one of us directly. So that is my email address and my Twitter handle. That's also the Twitter handles of a bunch of the other DAs. So that's Brent and Nathan, who we just saw examples of their work. Paul and Rick are both in the UK. So if you're looking for someone on the other side of the pond, there are lots of ECS and Fargate fans. And finally, just like Werner has said in the keynote this morning and at the other summits this year, please go build things. So everyone is a builder here. Go build, go innovate, go iterate, go build something cool. But I'm going to add one more thing on top of what Werner always says, and that's go build, but also tell us about it. So write a blog post, write a talk, go to a meetup, come and be a customer story here, come on Twitch, tweet me about it. But go build cool things, but then tell us about it, and then make sure that you tell the community as well. Because the community is what makes things like open source and these Amazon services cool, is people like you saying what you want to see us build, what you've built, this cool way that you've done this. So go build, go tell us about it. If this is the end of the road for you, I hope you enjoyed the New York Summit. There is, I think, probably one more breakout session after this today. I will be going back upstairs to twitch.tv/AWS. We'll be recapping, I think, around 6 p.m. So come and join us. Come hang out. I hope you enjoyed the summit. And if not, I hope to see you all at an event very soon. Thank you for coming.